This only concerns proportions. Hypothesis test for proportions. Confidence intervals for proportion. Say p hat is the estimate from our sample. The p hat is equal to 0.38. 38% of people want this thing versus want something else. The standard deviation for the confidence interval is p times 1 minus p divided by n. Take the square root of everything. So for a confidence interval, we have the z value times this s sub p hat, which uses the, in this case, it would be the 0.38. So we'd have 0.38 times 0.62 divided by, we'll give this sample size of 50. Why not? So that is the confidence interval for P in the confidence interval for a mean. I have the t-value times the standard error of the mean, where the standard error of the mean is s over the square root of n. Standard deviation divided by the square root of n. This and that are exactly the same thing. If I use my confidence interval for a hypothesis test, and that's not the way I want to say it. Just want mu in the middle there. Say if it's a 95% confidence interval, this is equal to 2, and I go that many standard deviations out in either direction. And then I look to see whether the hypothesized value, call it mu naught, it's got a number, is in that interval. If it's in that interval, and I've adjusted the interval for the alpha probability, then I've used it for a hypothesis test. So confidence intervals and hypothesis test are the same thing, except, come on, except when I have a hypothesis concerning a proportion. Here, the hypothesis is it's equal to P naught, whatever that is, versus it isn't equal to P naught. So when I do a test for a proportion, come on, you do something. When I do a hypothesis test for a proportion, I have whatever the p is plus the z value times the standard error of the p, and p minus z value times the standard error of the p, going the same amount up and down, and then I look to see whether the hypothesized value is in the middle, is in that interval somehow, right? This is the way I do it. It is not correct statistically. Right? For a hypothesis test, the standard error of the p-value has to be calculated as the hypothesized value of p. Instead of using the sample value to get the standard error, you're supposed to use the hypothesized value. What this comes to is, if I have a hypothesis that p is equal to 0.4 versus an alternative that it's not equal to 0.4. This is a two-tailed hypothesis. It doesn't matter what tail it is, it's all calculated the same way. If my sample proportion is 0.35, I went out and I got 35% who said yes, 65% said no. The standard error that has to be calculated is based on the hypothesis. Had 50 before, we'll do 50 again. So this is 0.24 divided by the square root of 50. What I do with confidence intervals is the error is equal to 0.35 times 0.65 divided by the square root of 50. I use this because I'm doing everything from the standpoint of a confidence interval. This is the correct way to do it. Use the hypothesized value for the standard error of the p.